Hello, good afternoon, everybody. Jose Daniel, I think you said everything about what is the future. Jose Daniel Garcia kept on insisting that the future is on 3D building. Is it my hair? Is it better? Okay, thank you. I will be trying to talk about a few projects today that also shows part of the future, but also of the present, and what is the technology possibility of today when we start merging them and we try to apply them into the architecture and construction scale. We see here an exhibition that it is full of small-scale products, I would say, and the challenge of 3D printing is really how we can bring it into the construction and into the one-to-one scale. This is something that we are working a lot at IaaC in an education and research center, and we're collaborating with companies such as Acciona in order to do pilot projects. I will be speaking, therefore, about what we call on-site robotics, because what is happening is that we are at a moment that we are regulated by regulations and by protocols that they assume that we are standard people and we have standard needs and therefore we need standard environments, no? This is the main manifesto and the principle of the second industrial revolution that brought the mass production not only of products but also of buildings. So this is our reality in many parts of the world because of this standardization. Now at the same time, if we have a look very quickly on a series of data, we realize that the buildings, they are responsible of 40% of the energy consumption in our planet, as well as 36% of the CO2 emissions. In parallel, we have an issue of housing problem. More than 100 million of homeless people, more than 1.6 billion people that they don't have an appropriate housing to stay at. And the need of the future, of how the housing need is growing. Every time more and more, according to United Nations, we will need more than 150,000 houses in the next 15 years. So how to construct quickly, how to construct in a customized way, how to construct in an affordable way and using sustainable materials and in a sustainable process is not only a very interesting idea, but it's really a big necessity. And what we think is that 3D printing, in collaboration with robotics and in collaboration with advances on natural and recycled materials, can give a solution to that a big, let's say, challenge. So we are working on combining those three technologies in a project that we called on-site robotics, because what we are interested in is to bring the construction on site, to bring that industrialization that has been extracted from the construction site, to bring it back on site. But not only bringing it back on site with the traditional heavy machinery, but start rethinking what would be the new tools for constructing and starting to think also which will be the new materials for constructing. So 3D printing is a revolutionary technique. I'm not going to say many details about it, but the main features is related with the fact that there is no waste material. We can deposit the material exactly where we need it. Therefore, we can produce complex shapes, but also it's a technique that it can take place directly on the site of where the construction is going to be happening. And that is creating a new aspect on material optimization. Now, the 3D printing has been used and is being used in different ways. One is thinking on prefabrication. Jose Daniel, in the project that we have also collaborated, showcased the first 3D printed bridge of the world, which has been printed in pieces, and it has been transported on site. It's a big revolution, but still showcasing some limitations in relation to the sustainability process of the construction. Now, what we have been working on the last year is to try to see what are the possibilities, the challenges, and the limitations of the 3D printing. This is one project when we started to realize that with contour crafting, we can start creating complex form, we can start getting deep into the research of the materials, that they can allow us to deposit them in a way so that they don't need any support material, but we also realized the limitation of what the tool we have been using was. So we couldn't print bigger than the machine itself. No, we could only print small products or small structures that they were not exceeding the range of the robotic arm and where this could reach. This is a combination of 3D printing, but also a combination of merging two thermopolyset materials, which means that according to the mix that you can give to those materials, you can accelerate the curing time. Therefore, you can allow another layer to be deposited upon it. We call it anti-gravity object modeling because it's basically printing against gravity. And this is one of the advantages of the contour crafting that we can get into this technique. So getting that challenge and that limitation of the scale, we started thinking that maybe if we create a series of robots that they can collaborate among them and we can get them on site, we can start imagining like bigger structures happening on site. Of course, the industrial robotic arms are not the appropriate machines for that. This is why we get deeper into investigate which machines could be giving us that solution. So that is a project that we're calling Mini Builders, and we have been working on creating 3 small robots that the goal of those robots, if you can maybe switch off the volume.
Architecture has always been linked.
Perfect. So the goal of this project was to create 3 small robots that they can print bigger than themselves. This allows to, let's say, give a solution to a series of challenges. First of all, we can go to places where there is no infrastructure, there is no need of transporting heavy machinery. On the other hand, we can also start thinking that the construction of big-scale structures are not necessarily component-based, so they are not necessarily prefabricated in small pieces that they can then be assembled and create something big, but the small robots themselves, they can really go on site and start printing in collaboration so that they can get smaller structures, bigger structures. The first robot is creating a base structure, the second one is a grip robot that is getting on that base and is printing while going a layer up, and the third robot is the vacuum robot that, as you see, in a very draft and rough way at the moment, but it's actually printing on vertical, which allow us to create a lot of 3-dimensional and complex structures. So following that same concept, or which are the tools for 3D printing, which are the future tools for 3D printing, which are those machines, we joined forces with Tecnalia. Tecnalia is a technological center in the north Spain, and they had this machine. This is a cable robot machine. It's the typical machine that they are using in stadiums so that they can take different kind of pictures and video recordings. And that machine is basically hanging and based on a series of cables and then some motors on the ground, which means that it is a machine that is not requiring a lot of volume. It's a machine that it is very easy to move and to be transported. So what we decided to do with them is to hack that machine. We went into Montpellier when they had their first prototype of that machine, and we attached a nozzle of 3D printing material. And we started creating a portable machine of 3D printing that it is basically a very small machine in terms of total volume, but it can really get into big areas of printing. So We used that technology in Construmat in May here at the Feria a few months back, and we set the goal to put that machine to use local material, which is clay, and try to print real time during the Feria as big as we could. So we ended up with a pavilion. We ended up with a pavilion that it was basically on a printing area of more than 10 per 12 meters, which is an area that it can also go bigger according to how longer those cables can be. And those are some of the images of the final pavilion, and those are some details of understanding how design, on the one hand, can allow of complex forms, but on the other hand, it can also enhance the behavior of the building. So we have been using clay, which is a natural material, and according to the design, we were able to create passive ventilation channels in the interior of the walls, which means that we were able to create passive ventilation, cooling and heating in the interior of the building without the need of external air conditioning. Now, continuing with the idea of the robots and the machines, which other machine is like really essential for 3D printing on site? We have been collaborating with Numena and developing a series of drones that they were flying around that construction, real-time construction, and they were scanning the building. They were scanning it on the one hand with a thermal camera so that we know whether the material was dry enough in order to deposit the following layer, but they were also scanning it in terms of design, 3D scanning, in order to detect errors of design. So that combination of different robots, cable boats, and drones, in combination with natural materials that they are require no firing, they are natural, they are biodegradable, they are low cost, they can be found on site. So we don't need to really transport them. This starts to open up possibilities of revolutionary 3D printing processes on site where, as you can see, the material cycle is really based on the resources that we can find there. This can give possibilities and solution to places that there is no resources, to different kind of refugee camps, but also to the urban environments. That is a parallel research that we have been doing on recycled bioplastics. Bioplastic materials that they are based on organic waste of coffee and orange. So we have created a material that it's not the soil that we can find on site, but it's the waste of our cities that it can feed those constructions. I'm not going to go much deeper into that material, but it's just only to introduce to you that there is a series of possibilities of different natural and sustainable materials that we can use. I'm going to end up with this video, which is an animation that shows our vision of the very close future and also of the present. So with a truck, we can go on a site that there are no resources. Small robots, if I can have a volume now, that would be nice. Small robots are going out of the trucks in order to scan the area, to scan the quality of the soil so that we can have data on what we can do with that material. Then the relationship among users, clients, designers, architects, and constructors is changing. Through a series of interfaces, they can be in constant collaboration. The client can start customizing their design. They can even start customizing the production process. So is it going to be a 3D printing? Is it going to be a combination of series of robots? What would be the impact in terms of money, in terms of environmental cost? And then the cable board is coming on site very easily. It is being assembled, and then we use the material on the site in order to start printing big houses. And this is the scenario where, as I said, there is not enough infrastructure. In a very simple way, that structure is being disassembled, again, is even able to be loaded in a truck. And then if we go to the scenario of the urban environments, for us, it's very interesting because it is the big challenge, no? It is what I was saying in the beginning. How can we give solutions to the increasing urban population? So this is a truck that is actually going around the neighborhood to collect organic waste. And then a combination of bioplastic and recycled materials can allow us to start envisioning that this could be directly used as the material of the future, as the construction material that would be used on site in collaboration with robots, but also in collaboration with the users, the clients, and all the material waste that we're producing in urban environments. So I'm just going to leave you here saying that this is a research that is including a lot of great people. This is also a research that we are pushing further together with companies such as Technalia, but also Acciona. And thank you very much.
Wonderful. Wonderful. Areti,
On time?
here, going down for a second.
Thank you.